Yes, I know you need a second to turn the recording on. Just as a reminder, we are recording this session. Couple of logistics as we start our afternoon session. For those of you who are joining us for the first time and were not with us this morning, we are using Microsoft Teams. If you have questions during the course of the presentations, we ask that you write them in the chat. The chat is this little chat box up here at the top. Also, if you have questions during the Q&A portions of our sessions, please raise your hand. You can see the little hand icon up here at the top, and we will call on you. We're doing our best to answer all of your questions. For those questions that we are unable to answer because of time, or because we need to do more research, we will be preparing responses and posting them on our website and sending the link to you following our summit. So at this time, I would like to introduce Gary Buchanan, who is going to be facilitating or moderating the next session. Gary is our director of the Division of Science and Research. And so I'll turn it over to you, Gary, to talk about your session. Thank you.
Thank you, Carrie. Good afternoon, everybody. I hope you had a nice break and a nutritious lunch. And hopefully this science session will keep you interested. So I'm going to introduce Dr. Gloria Post. She's going to give a summary of what the division has looked at over the past year in terms of cyanotoxins. And also the look at an additional cyanotoxin, saxitoxin. So Gloria, can you please start your presentation? Thank you.
Thank you. Can you hear me?
Yes.
Thank you. Thank you for inviting me to speak here. So I'm going to be talking about, as Gary mentioned, potential updates to the current cyanotoxin recreational advisories and calculation of a saxitoxin advisory and additional cyanotoxin for possible inclusion in the 2021 HABs strategy. Next slide, please. So just as an overview of what I'm going to be talking about, recreational advisories for cyanotoxins are intended to protect for daily swimming exposure in children for the duration of a HAB event. Advisories are based on both toxicity and exposure assumptions. The toxicity factor is a short-term reference dose in micrograms per kilogram per day. It's the daily oral dose expected to be without adverse effects during the relevant time period. The exposure assumptions have to do with incidental ingestion of water during swimming by children because children ingest more water than older people while swimming on a body weight basis, and that is liters per day of water ingested and the body weight of a child. In 2020, the Division of Science and Research reviewed the basis of the current advisories for cyanotoxins, microcystin, cylindrospermopsin, and anatoxin that were developed in 2017. Based on the literature review of more recent peer-reviewed toxicity studies, that no revisions were recommended to the reference doses. The literature review, the newer studies provided additional support for the current reference doses. The revised exposure, there was a recommendation to revise the exposure assumptions. A more recent 2019 US EPA analysis of children's exposure from incidental ingestion while swimming was concluded to be more technically sound than the 2017 assumptions used in the 2017 advisories. It wasn't available, obviously, in 2017. It's from 2019. Also, as Gary said, the Division of Science and Research has developed a reference dose that could be used in a potential recreational advisory for saxitoxin. Next slide. As far as the exposure assumptions for child ingestion while swimming, as I said, the assumptions include the daily ingestion in liters per day, and that's based on how many liters, the volume swallowed per hour, liters per hour, and how long a child would swim each day in hours per day, as well as the body weight in kilograms. The 2017 advisories use the current advisories developed in 2017 used 0.12 liters per day ingested and 1 hour of swimming per day for a child less than 18 years old. In 2019, the EPA analysis became available, and the assumptions they provide are 0.21 liters per day for a child age 6 to 10, which is the age group with the highest ingestion rate. And this was based on a newer analysis that had 10 times more subjects than the earlier study. The data showed that the mean and median swimming duration was greater than 2 hours per day, and the 0.21 liters per day is based on combining the distribution of the ingestion rate and the duration for the 90th percentile in the combined distributions. Both the older assumptions and the newer assumptions used a same body weight, 31.8 kilograms. The Division of Science and Research concluded that the newer US EPA value is more technically sound than the older value and recommended its use. Next slide. The rest of my talk, most of it will focus on the cyanotoxin reference dose developed by the Division of Science and Research, and Dr. Brian Pachkowski of DSR is the lead on this project. Cyanotoxins produced by cyanobacteria in freshwater and in marine environments by dinoflagellates. The primary toxic effect in humans and animals is neurotoxicity. It prevents transmission of nerve impulses to muscles and can lead to respiratory arrest and death. Cyanotoxins, well known for causing paralytic shellfish poisoning, or PSP, from consumption of contaminated shellfish. Other potential effects such as systemic, meaning like liver or kidney toxicity, organ toxicity, developmental, reproductive, and immune effects have not been thoroughly studied. The reference dose is intended to protect for 24 to 38 hours, 24 hours to 30 days, and it's based on a literature review for relevant peer-reviewed studies, review of values developed by other agencies, and an external peer review by 3 national experts. Next, please. So the laboratory animal toxicology studies are limited and don't provide useful information that's useful for risk assessment. The risk assessment's based on human paralytic shellfish poisoning case studies that have been compiled and reviewed in several reports and publications. The 2 most useful ones were from the compilations and reviews were from European Food Safety Authority, or EFSA, and that is the basis of other states' advisories. They provide a no observed effect level of 0.5 micrograms cyanotoxin per kilogram. They do not provide data from the individual cases. A more recent paper by Arnich and Thable recently became available, 2018, a peer-reviewed journal publication. They did modeling to derive a dose with a 10% probability of symptoms to come up with a value of 0.37 micrograms cyanotoxin as the lower confidence level on that dose. It's similar to the benchmark dose modeling that New Jersey, other states, and EPA use in risk assessment for other contaminants. They also used a systematic review approach that excluded poor quality data, and they did provide data on individual subjects. This was selected as the basis for the reference dose after review by the Division of Science and Research statistician. Next slide, please. So this shows how the reference dose was developed. As I said, the point of departure was the 0.37 from the Arnich and Thable review, but this was for acute exposure and not for a reference dose such as we're developing for longer exposure up to 30 days. And for other effects. We applied uncertainty factors as appropriate to derive the reference dose, which I'll talk about. No adjustments needed to extrapolate from animals to humans because it's based on human data, not animal data. We applied an uncertainty factor of 3 for more sensitive individuals, such as children or those who might be genetically more susceptible. This was based on external peer review comments from all 3 peer reviewers, who all 3 of them independently made the same recommendation. The duration of exposure factor is 3 because the point of departure is based on acute exposure, and we are developing a reference dose for up to 30 days. We did not need to use a low L to no L because we're not using a low L. And the database uncertainty factor was applied because there's almost no information on other potential health effects, developmental, reproductive, immune, and others. So the total uncertainty factor is 100. Just to clarify, when we use factors of 3, they're really not 3, they're the square root of 10, which is higher than 3 a little bit. But so when you have 2 factors of 3 in risk assessment with the uncertainty factors, 3 times 3 is 10, not 9. That's why it's 100 and not 90, resulting in the short-term reference dose of 0.0037 micrograms per kilogram per day. Next slide, please. So to derive the recreational advisory, we combine the reference dose with the exposure assumptions, the body weight, and the ingestion rate as shown here, resulting in a value of 0.56 micrograms per liter, which was rounded to 0.6 micrograms per liter. Next slide, please. So just as a summary, the potential changes to the recreational advisories based on the updated exposure assumptions. As I said, there was no change to the toxicity basis, and the use of the updated exposure assumptions from US EPA would result in less than a 2-fold change in the existing advisories as shown in the table. Microcystin from 3 to 2, cylindrospermopsin 8 to 5, anatoxin A 27 to 15, and then the new saxitoxin advisory of 0.6. Last slide, please. So just the summary and next steps. To summarize, a recreational advisory for saxitoxin and updates to the existing advisories for the other toxins have been developed by the Division of Science and Research, and they've been shared with the New Jersey HAB work group for consideration. These new and updated advisories are under consideration for possible inclusion in the 2021 New Jersey HAB response strategy. Last slide, please. So thank you, and if anyone has any questions, feel free to contact me at my email address that's on the slide. Thank you.
Yes, thank you, Gloria. And we'll also, at the end of the session, we have some time, so please hold your questions till then, or write them in the chat room. Thank you, Gloria. Okay, next up, I'm very pleased to announce that Karen Stainbrook accepted our invitation. She is with the New York State Department of Environmental Conservation with the Lake Monitoring and Assessment section, and she's going to talk about some of the techniques that they use in New York for mitigation of harmful algal blooms. Karen?
Hi, can you hear me, Gary?
Yes.
Okay, great. I had to unmute myself twice, I think. Okay, thank you so much for the invitation to present here today at this HAB Summit. It's been really interesting this morning, and I commend New Jersey DEP here for this. This is great. So in addition to the HABs efforts, the HABs program, which includes the NIHABs reporting system, which is similar to your New Jersey DEP dashboard that you were talking to. We operate that in New York State in partnership with the New York State Department of Health and the Office of Park and Recreation and Historic Preservation. And we have HABs research and HABs mitigation studies. In addition, my section oversees the collection of water quality data throughout the state of New York. Next slide, please. Okay, so here's an outline of what I'll be sharing with you today. Since the other speakers spent a lot of time already going through all the background on what cyanobacteria is, I have no slides on those. I'm just going to get right into the mitigation projects that New York State has been working on. So first, I'm just going to give an overview of New York's HABs initiative, walk through the mitigation strategies that were conducted in 2018 and 2019, and refer to them as our HABs 1.0 and our HABs 2.0 projects. Briefly discuss a small workshop that we held in 2019, and then finally walk through New York's 2020 HAB mitigation deployments. And I want to just say here before we move to the next slide that it's not a team of one, it's a team of many here, and we all work together on this project. So I will answer the questions best I can, but I may also need to go back and get some help on some of those depending on what they are. Next slide, please. So in 2018, Governor Cuomo announced his HABs initiative. The key efforts for this initiative that are still ongoing are to identify what the contributing factors are that cause HABs, find ways to lessen the frequency and or impact of HABs, and protect and conserve the water quality of New York's water resources. So since over the last 2 years, approximately $189 million has been invested in this initiative. Most of those resources went to implement water quality improvement projects within priority watersheds across the state. We held 4 regional summits to understand how HABs are impacting different types of lakes across the state of New York. We developed priority water body action plans, HAB action plans. In addition, we conducted some advanced monitoring on several water bodies across the state. And finally, we also piloted some mitigation projects, and that's going to be the focus of my talk. Next slide, please. So taking a step back for a moment and thinking about the different types of strategies, mitigation strategies that we have, there are really 2 main types: watershed management and in-lake management. So watershed management, is most of us are familiar with, are to reduce nutrients at its sources, and there's some tried and true tools that we have, like wastewater treatment plant upgrades or best management practices like riparian buffers, stream bank stabilization, or stormwater management. These are great in the long game in terms of preventing or stopping nutrients from reaching water bodies, although these efforts take many years to see the impact and the change within the water body itself. So coming up with some interim or in-lake management strategies, not only to control nutrients if possible internally, but also to control bloom formation and size. So chemical treatments or physical treatments, and keeping in mind all the complicated other factors like climate change and invasive species along with that. So New York State's been evaluating commercially available and newly developed strategies to test their effectiveness that may potentially provide short-term relief from HABs and increase water body use, the different technologies that could be used in an emergency response or as an interim solution or in some sort of surgical application, again, to get at protecting or allowing the best use of that water body. Next slide, please. So there are some other factors that we have considered and should be considered within in-lake management approaches is the lake itself, lake size and depth and morphology, what types of HABs form there, whether they're widespread or in the open water, or it's a shoreline bloom accumulation, or whether it's just a small bloom right by someone's dock, or whether it's a large bloom that covers the entire lake throughout the entire water column. If there's some sort of permitting required in order to use the device itself or use the treatment itself, and then also if there are any unintended consequences or, for example, a treatment of non-target species. And then some other things is to think about, and I think one of the other speakers touched on, is that there's no one particular strategy that's going to fix all blooms. There's no silver bullet HABs mitigation device that's going to fix blooms on all lakes everywhere. And so what works on one lake may not actually work on another lake, and taking all those things in, as well as continuing to understand what are the factors and mechanisms that are contributing to HABs, to help us further develop these methods of control. Next slide, please. In addition, we are also evaluating these types of factors, mobility of the technology. How quickly could a device or a treatment be deployed to a water body, getting at that sort of rapid response aspect? How maneuverable is the technology or the treatment? Can it be used in the entire water body? Is it only an open water area? Is it can only be used along the shoreline? What's the flow through of that? How much water can be processed or be treated through that particular device? And then in consideration with what volume of water are we trying to treat? What is the energy consumption? What is the energy being used? And what is the cost of that? What is the impact of that energy consumption? Footprint. Does this technology or treatment require a shoreline space or a staging area? Are there multiple units? Are there multiple staging areas for deployment? And then, of course, cost. How expensive is this technology or treatment relative to its effectiveness? Next slide, please. Okay, so now on to the technologies that we've piloted over the last few years, starting in 2018. So the following slides cover the basic concept of each treatment, if there's permits applicable, New York State permits applicable, how the treatment was piloted, and what our initial findings and takeaways are. So I don't get into any of the details about, I don't take a deep dive into the entire study of these. I'm just covering them generally. And also to note, we are still in the process of going through all this data. So hydrogen peroxide or hydrogen peroxide-based products, they, when applied to the water body, oxidize cyanobacteria and cyanotoxins and essentially break it down into water and oxygen. And in New York State, that requires a pesticide permit. And we piloted biweekly treatments of half of a lake, as well as biweekly treatments of a small area in and around a beach. What our initial findings, we found that the treatment was most effective when the phytoplankton diversity was high, and it was initiated prior to a full lake bloom. So when there was high diversity, the bloom didn't reoccur as frequently or as quickly as the areas that did not have a lot of phytoplankton diversity. So some of the takeaways for us that might be useful if we were going to use hydrogen peroxide-based products in the future would be to apply more frequently or higher doses, or have a larger treatment area, to understand what the plankton, the phytoplankton, and the zooplankton communities are in advance to help us maybe be more effective with the treatment. Also to consider treating at depths where chlorophyll and DO concentrations are present, where the cyanobacteria are most likely to be within the water column. And then also considering a multi-formulation approach. So perhaps application of a granular solution in the early in the season to target the benthos, and then on a liquid application throughout the growing season. Next slide. So New York also piloted the application of alum to evaluate its efficacy to control and its HABs, and as well as evaluate the potential environmental impacts associated with this treatment. So currently in New York, there is not a permit pathway for alum treatment. So this was done as a pilot and study to understand this. So basically, alum binds and reduces the bioavailable phosphorus in the sediment in the overlying waters. We treated 2 lakes in the late spring outside of the growing season. We just actually finished collecting our monitoring data this past year, so we don't have a lot of findings yet to share since we're still analyzing that data, but we did document that there was a reduction in total phosphorus within the water column. So some things just based on, our initial thoughts, perhaps applying a treatment in the fall when soluble phosphorus concentration is higher, perhaps a higher dose over a longer period of time. It's more costly, but it addresses some environmental concerns regarding changes in pH. And to make sure that before this treatment occurs, is that the land side or the watershed side of the external pollution sources be properly addressed prior to treatment. Next slide, please. So ultrasonic devices, they emit high-frequency sound waves that damage cyanobacteria gas vacuoles, resulting in the cyanos to sink and die. They are powered by either solar or electric. So far, we have required, at least in our application, just a floating object permit, which, because these are anchored within a water body, they potentially are a navigation hazard, so we need to get them permitted. In our initial treatments, we just had a single unit in an isolated cove, and what we saw was there was really no difference between the control and the treatment site. However, there's a lot of documented success where it's mixed. So there is some literature that suggests there are some scenarios where it may be effective. So we think that maybe more work would be needed to demonstrate with larger units or more units per area, as well as an improved monitoring design. Our study design for our 2018 project didn't collect data that frequently, and we think that having a more robust study design would help us better understand the efficacy of this type of technology. Next slide, please. In the fall of 2019, New York State contracted with a private firm to demonstrate a shoreline small-scale deployment of the algae harvester. It uses a dissolved air flotation unit, hydrogen peroxide, ozone to treat the toxins, so it removes the algal biomass and oxidizes the cyanotoxins. In this case, the power source was a generator, and it is a speedies pathway. So it was evaluated by our permit staff here in Division of Water prior to deployment. So this unit was set up on the shoreline of a 64-acre lake that has widespread high toxin late season blooms. What we found was that there was a reduction in HAB cells and toxins, and then nutrients were reduced, but not completely, and this is as it is through the system. We did not find any change in lake water quality, and it is a unit that can be driven to a location, but it's not mobile in and of itself, in that this particular water body, when the prevailing wind changed, the bloom moved from one end where the device was located to the other end where the device wasn't located, and we couldn't just pick it up and move it. Some takeaways: we need this device could really warrant a rapid deployment, as well as a streamlined permitting process, perhaps. The mobility should allow treatment anywhere within the water body, which would be great, and identify alternative power and chemical treatment options, greener types of treatments, different types of power for the system as opposed to like a diesel generator, and then scaling it up because this was considered a demonstration project. Next slide, please. Thank you. So in the fall, later in the fall, in 2019, after all the initial pilots were deployed in 2018, we were looking for some new innovative technologies to evaluate. So New York State DEC held a small workshop with some of our federal and academic partners to identify some of the most viable HAB mitigation solutions for 2020 and to develop some collaborative relationships among our mitigation leaders. And so the following slides provide an overview of the technologies that were piloted in 2020 as a result of this workshop in 2019. Next slide, please. So in partnership with the New York State Center of Excellence on Healthy Water Solutions, which is co-chaired by Clarkson University and the State University of New York, Environmental Science and Forestry, which I will refer to as ESF, piloted an innovative electrochemical oxidation and filtration technology. So this essentially is a tube with a metal tube with a bunch of holes perforated in it where electric potential is applied, and the naturally occurring chloride is oxidized into chlorine, and hydroxyl radicals are produced, which oxidizes the cyanobacteria and the cyanotoxins. So there's no chemicals that are added to this process.
Karen, can I just ask you to take a minute or so to wrap up?
Oh, yep, absolutely. I'll go quickly. So this is still in R&D. There's more work to be done here. So more to come on that. Okay, you can go to the next slide. Sorry to go through that so quickly. We also piloted a hydrodynamic cavitation and hydrogen peroxide pilot with ESF, and it basically, the water is pushed through an orifice plate that creates these bubbles, and when the bubbles collapse, there's heat and pressure, and it damages the gas vacuoles. They used hydrogen peroxide-based product as well in that treatment. There is some reduction in chlorophyll and ugotoxins as with the other, but there is some continued work that's being done by ESF and Clarkson both to refine these different technologies to be able to be treated up, to be able to be moved around, and understand any potential impacts to non-target species. Next slide. And then I'm almost done here. Last one. Habitats was also piloted in 2020 in collaboration with the Army Corps of Engineers Engineer Research and Development Center. And Habitat system was deployed in two different forms: a shoreline unit, which is similar to the one that was deployed in 2019, as well as a shipboard unit. Applies the same type of technology, dissolved air flotation device, dewatering, ozone, as well as then a transformation of that algal slug using hydrothermal liquefaction to create some sort of biofuel. So the idea is that Habitats is a unit that is, net zero waste or energy neutral. And so there were some preliminary findings to show that HABs, biomass, and toxins were reduced. It helped to validate the shipboard design, and that the systems both worked well onshore and offshore. Onshore and shipboard. So there's still a lot of work that Army Corps is continuing to work through. And then next slide. So just some future outcomes, and I won't go into all of these, but we're still working on all the results, and we anticipated a better understanding of how these technologies, of these technologies, if a bloom is removed, are there still toxins there? What are the changes in water quality? What are the impacts to the phytoplankton, zooplankton community? Are there impacts to what's the fish response to different types of devices, as well as our continued evaluation of nutrient inactivants? And then I will just go to my last slide because you asked me to wrap up. So thank you, and happy to answer any questions.
Thank you, Karen. It's great to see that both states are on the same path for some of these, but also to see some of your new and interesting mitigation techniques. We're going to hold off the questions until after this last talk on the science section. Let me introduce Dr. Rob Newby, Division of Science and Research, who's going to talk about the Interstate Interstate Technology Regulatory Council team that's working on a management tool for HABs. Rob.
All right, thanks, Gary. So I'm Rob Newby. I am a research microbiologist with the Division of Science and Research, NJDEP. Myself, along with Vic Peretti, were members of the Interstate Technology Regulatory Council, or ITRC, harmful cyanobacteria bloom work group. I was a leader of the management subgroup, so I'm going to be presenting to you one of the outputs of that document, which is due out later on in spring. Next slide, please. So very quickly, introduction to management is managing blooms is challenging. You can ask any manager, any leak owner, anyone who's ever had to deal with the cyanobacteria bloom, and they'll tell you that it's extremely challenging and that there's no one size fits all approach that works for blooms. So one of the issues that you can sort of look at is that you can treat management almost like two different things. You can do management to prevent a bloom, or you can do management to intervene when the bloom is ongoing. Next slide. So by that, we mean directly intervene. So intervention is directly intervening when a bloom is already formed, and prevention is where you're actively using something to prevent the formation of a bloom, whether you know you're historically prone to blooms or you know that there's some indicators that blooms may be ongoing or upcoming. So we devised a sort of fact sheet that came along with a number of technologies. So each strategy we evaluated was basically assigned to a matrix, which could be useful to help people have discussions with lake managers or with certified pesticide applicators to basically guide the discussion so that you can understand what's been used, what's been evaluated, so on and so forth. Next slide. So this is what the tool looks like. It's still very much beta, but essentially what you're going to be able to do is you're going to be able to go onto the ITRC web group web tool, and you're going to be able to basically click on different categories, whether or not you want something that's going to prevent a bloom, treat an active bloom, how much supporting field data there is. This is actually really important because a number of techniques are still emerging. So you heard Karen, she had mentioned that they're piloting a number of projects. A lot of these don't have wide scale use yet, so they're emerging or they're very limited. So you may want to limit, based on that, whether or not your water body is a pond, a lake or reservoir, how big the water body is. If you know some of the information about the hydraulics, like residence time, the nutrient conditions, the depth, that'll all be helpful to help limit some of the different things. So next slide. So this is an idea of what it's going to look like. You'd basically click on these different things and it would output a list of techniques that the ITRC management group had evaluated. Next slide. And clicking on any one of those links underneath will bring you to the fact sheet. And the fact sheet's broken down basically in several sort of subgroups. So the name of the strategy, whether or not it's intervention or prevention, and how much data there is in the field for this. So ultrasound is one that's pretty popular. So the write-up about what the basically what the technique is actually doing is included. That's in the strategy info. Next slide. Further in where basically it's been deployed and how effective it is, any limitations, any advantages. So again, there's no one size fits all approach that is applicable for every bloom. So while ultrasound may work for planktonic blooms, it won't work for benthic blooms. It also won't work for cyanobacteria that don't regulate their buoyancy via gas vacuoles. Next slide. There's also a cost breakdown. So with this, there's going to be several training sessions that are going to be available for free. You can find those once the document is released later on in spring 2021. And I would direct you to please check out itrcweb.org for the specific dates and the training schedules that are going to be available. And that's it.
Well, thank you, Rob, for getting us caught up a little bit there by speed talking. Appreciate it. Okay, now we have time for questions. Let me just read some of the questions. First one was from Leslie McGeorge for Gloria. How does the proposed New Jersey saxitoxin advisory level compare to other states or countries? And is the level proposed quantifiable with the ELISA method? I can answer that second one. Yes, it is quantifiable. The reporting limit is 0.02. And the value we came up with is what? 0.6. So yes, you can detect it. So Gloria, you want to take the first part of that question, please?
Yes, thanks. So at least 5 other states have developed saxitoxin recreational advisories. All of the others are acute, whereas New Jersey, which would be for a single exposure, I presume, whereas New Jersey's, as I said, is shorter term, which means for up to 30 days of exposure, so they're not directly comparable. Pennsylvania and Ohio's value is 0.8, which is very close to the 0.6 that New Jersey has developed. Their their water ingestion rate is similar to what is not the higher rate that EPA has recently developed, which is based on the newer study. It's lower actually than New Jersey's current rate. So if those exposure assumptions were applied, it would be lower than New Jersey's. It's close. The other 3, Colorado, Oregon, and Washington, have higher numbers. So again, they're acute and not short term.
Great, thank you, Gloria. Next question is for Karen from Fred Lubnow. Will or did New York State DEC also evaluate the algae harvester system at Chautauqua Lake?
Yep, at Chautauqua Lake, that's where the 2020 deployment was. So was the shipboard unit as well as the shoreline unit was deployed in Chautauqua Lake in late summer. And I didn't get a chance to say it, but there is we have on our New York State HABs page, we do have a section just dedicated to HABs mitigation, and we will be adding new information there. There is a couple of presentations that we did last year that cover the Chautauqua Lake project, as well as the electrochemical oxidation and the hydrodynamic cavitation projects.
Okay, and last question from Steve Souza. Hey, Steve. Any documentation of the harvester unit on zooplankton or fish larvae?
We don't have any documentation on that, although one of the things we're going to be including in future monitoring projects for all the devices is that non-target species impacts.
Okay, I think that's all the questions we have. Wanted to thank the 3 speakers and look forward to seeing that tool from ITRC, which I think will help folks on this call. Back to you, Carrie.
Thank you, Gary, and thank you, speakers. That was terrific. We're going to be moving on now to our next session that's dealing with best management practices. This will be moderated by Bruce Friedman. Bruce is the director of the Division of Water Monitoring and Standards, and he'll introduce our speakers. Bruce?
Thank you, Carrie. Good afternoon, everybody. The next session, which I'm moderating, is on best management practices. Water quality is greatly impacted by stormwater runoff, which is amplified by continued development and the addition of impervious surfaces. To minimize the impact of stormwater runoff, developers are required under the new stormwater rules to implement green best management practices that use or mimic the natural water cycle to capture, filter, absorb, or reuse water. To talk about best management practices for both new development and existing development with a focus on nutrient removal is Dr. Chris Abrupka, Director of the New Jersey Water Resource Research Institute at Rutgers University. Dr. Abrupka?
Thanks, Bruce. Can you hear me? Is it okay?
Yep, you're good.
Excellent. So, yeah, I don't know about you, but my head's kind of spinning. There seems to be a lot of in-lake practices to actually deal with HABs, and wow, a little bit overwhelming. So you can go to the next slide. I run the Water Resources Program for Rutgers Cooperative Extension, and my job is really to run around the state and help people solve their water problems. So we've been dealing a lot with stormwater management recently. You go to the next slide. So water quality is a big issue that we're dealing with, right? So whether it's harmful algal blooms or anything else that's kind of making its way to our streams and our lakes, there seems to be consensus that I've been hearing all day is that, you know, there's in-lake processes, but we really need to keep nutrients from flowing into our water bodies, and that will help greatly preventing these harmful algal blooms. So there's several ways to do that. I'm going to really talk a lot about that today. You can go to the next slide. There's pre-manufactured treatment devices, these hydrodynamic separators. The technical name for this is the swirly device, where water comes in and swirls around and magically everything settles out. These remove about 50% of the sediment and usually only about 25% of the phosphorus. Sometimes they get a little bit more. The next slide will show you a filter system. And these are a little bit better. They get a little bit better sediment removal, a little bit better phosphorus removal. But once again, there's filters in here. They have to be replaced regularly. You think of this like a Brita filter that might be on your faucet. So you have to replace these cartridges or take them out and clean them on a regular basis. So that can be pretty expensive. So both of these types of devices are rather expensive, but they can be easily retrofitted into existing development. Bruce was talking about, you know, new development, but a big source of pollution is existing development too. So we have to deal with that. So next slide probably talks about a little bit better green infrastructure. So now what we're trying to do is we're trying to capture stormwater near its source, filter it, absorb it, get it back into the ground, and reuse it wherever possible. Next slide. So there's a bunch of different green infrastructure practices, and I kind of broke them down in a few categories here. Bioretention systems, and the rain garden is the most popular practice that we have. Permeable pavements, we do have a porous asphalt, a pervious concrete, permeable pavers. Rainwater harvesting is another great way to manage stormwater. We have dry wells. Once again, you're capturing water, you're infiltrating it back into the ground. And then we have these kind of rooftop systems, green roofs, blue roofs. Pretty interesting system. So I'm going to go through a few of these. You go to the next slide. So the rain garden is interesting. It's really just a shallow landscape depression. The idea is supposed to capture stormwater, hold the water, let it slowly percolate into the ground. The plants will take up the nutrients. So all this stuff is maybe the water will eventually get to the lake, but it's going to go through the groundwater table. So it'll be cleaner and cleaner, and a lot of the phosphorus will be removed. And phosphorus is the main problem that we see a lot in freshwater systems. The next slide will show you a little bit smaller system that individual homeowner could put in. So now we're taking roof runoff or driveway runoff, and we're putting it into these little gardens, and we're also managing that water. We could take runoff from our yard. So anything that might have phosphorus or nutrients in it, we're going to capture in this garden. We know phosphorus settles out of the atmosphere, so anything that lands on our roof would be captured in this and be treated. The next slide talks a little bit about porous asphalt. This is a really interesting system because now what you're doing is you actually have asphalt that water can pass right through, and it'll go into a stone layer underneath and slowly percolate through that stone and percolate into the ground. And now you're getting the water back into the ground. And one way to treat stormwater, the best way to treat stormwater, is to infiltrate it wherever we can. So the next slide will show you another type of permeable pavement. Oh, this will show you a cross section of it. So this is interesting because it actually shows you the stone layer underneath the parking lot. Now that stone layer can be as thick as you need it to be. If you wanted to manage just a water quality storm, 1.25 inches of rain over 2 hours, that may only need to be 6 inches thick. If you wanted to manage the bigger storms, you know, the 100-year storm, you know, that layer could be 4 or 5 feet thick, you know, so it depends on what you're trying to manage. So next slide will show you grass pavers. Another type of permeable system, you know, so once again, there's a stone layer underneath these concrete blocks and grass growing through them. Water can pass right through this. What's nice about this is you can still drive a fire truck on this and it won't sink into the ground. It'll hold it up. So the next slide will talk a little bit more about how to do this kind of work. So we do planning, and I actually borrowed this from Princeton Hydro. So they've done a plan for the Deal Lake, for example, a watershed protection plan. These plans are a little expensive to do. They require data collection and some modeling and stuff. And really, it's meant to be a blueprint of how to fix the lake. So we've kind of done something a little bit different here at Rutgers. The next slide will show you it's a green infrastructure feasibility study. We're going into the town. You go next slide, and actually going into the watershed and identifying projects within the watershed. So here we've identified 17 sites that are really just low-hanging fruit. You can go in right now today and put in green infrastructure and actually manage stormwater from these existing developed sites. And for each site, we have 2 figures, and the next slide will show you one of those figures. So we show you an aerial photograph of the site. We show you where the stormwater planters are going to go, where the rain gardens are going to go. We show you the drainage area. And the next slide for that site would show you all the information of that site, of what we're recommending, how much stormwater runs off of this site, how much phosphorus comes off of this site. So we have this information here so we can understand what this practice might cost, how much water it's going to manage, how much sediment it's going to remove. And you go to the next slide and we can show usually a before picture, and then the next slide would show you an after picture, right? So this gives people a feeling of what it could look like, okay? And this is just an artistic rendering, but it gives people an idea of what we're trying to put in the ground. So the next slide will show you a little bit more about what we can do, because someone asked earlier about, well, I'm a homeowner, what can I do? What are the 3 things I can do? Well, one thing is you can build a rain garden, you can install a rain barrel, and we have different programs for that. The rain barrel program is interesting because the AmeriCorps ambassadors kind of run those now, but we here at Rutgers actually run a rain garden rebate program. We're doing one right now for Lake Apacon. You can go to the next slide. What happens is people come in for about an hour talk, or they listen to me online now for an hour talk. We tell you what a rain garden is, why you want one. So it's really a hard sales pitch on why people should build rain gardens and how to do it, how to build it, how easy it is. Then they sign up for a design session. They come in for half an hour. We sit down with them. We actually design a rain garden with them. They meet with an engineer and a landscape architect. They help pick out the plants. On the left side is the design they get. On the right side is what they wind up building. And you can go through the next picture, shows you another one. This one's actually taken driveway runoff, rooftop runoff, and sump pump runoff, all going into this little rain garden here. And the next slide will show you another one. Some people get carried away. We design a little rain garden, and they want, when they build something much bigger, taking many downspouts in instead of just the one we originally recommended. And then the next slide will show you another picture, and this is a Toby Horton, our landscape architect, and the upper right-hand corner is the before picture, and the bottom on the left-hand side is the after picture. So one more slide and I'm done. And so Rutgers Cooperative Extension, I mean, we have some programs here. The way it works, I'm faculty, so I get paid for by the university. I have about 10 full-time staff who work for me, all on grant funding. So we've been helping communities with watershed restoration protection plans and green infrastructure feasibility studies and these rain garden rebate programs. We have a green infrastructure champion program where we train people about green infrastructure so they can be their local champion and try to get things moving in their town. And we also assist people with grant writing. So there's my contact information. If you ever need to reach out to me, you can send me an email. And that's it. Thanks, Bruce.
Thank you, Chris. Appreciate it. Obviously, how we develop and where we develop greatly impact New Jersey's water and water resources. Integrating land use practices and planning with water quality in mind is a department priority. Next up, we have Elliot Ruga, Director of Policy and Planning for the New Jersey Highlands Coalition. We'll share some thoughts on how development impacts our water resources and the importance of watershed management. Elliot?
Yeah, Bruce, can you hear me okay?
Yeah, I hear you great.
Great. Hello, my name is, and Bruce, I won't need a time prop. I will end on time.
Okay.
Hello, my name is Elliot Ruga. I'm the Policy and Communications Director of the New Jersey Highlands Coalition. I'm here as a representative of the environmental advocacy community. And indeed, the presence of harmful algal blooms is a priority concern of ours. I should point out that the views expressed by me are not meant to represent the department, and the department has neither previewed nor endorsed my presentation. Next slide, please. Once upon a time, in the far northwestern wilderness of the land was a great pond. This was a beautiful mountain lake fed by springs and the streams that flowed from the surrounding wooded hillsides. The water was crystal clear and cold. Next slide. Eventually, people from the land's far cities discovered the great pond, and they fell in love with it. Soon there were resort hotels on the pond's shores. A railroad was built to bring people from the city, as this was in the days before automobiles. Next slide, please. And because This was also at a time when canals were being built. A dam was constructed at the outfall of the pond, and the pond was made even larger. Next slide, please. So they could use the pond to water a new canal that went from one end of the land to the other. Next slide, please. This was a vibrant time on the Great Pond. Summer bungalow communities sprang up all around the pond. Families would come here for summer weekends to swim, to boat, to fish, to hike in the nearby woods. Overall, the land was prospering. Many more and more towns and villages had sprung up, and these towns and villages grew into cities. Many, many more people now lived in this land, and many of them came to the Great Pond, for it was truly a special place that more and more people grew to love. Next slide, please. No longer willing to stay at the pond for only a few months every summer, people wanted to make the pond their home, and they transformed their bungalows so that they could stay through the harsh winters. Next slide, please. And soon enough, as the land continued to grow and prosper, the pond was no longer far away, as villages and towns sprang up closer and closer to the pond. And as more and more people built houses around it, villages and towns sprang up on the pond's shores too. Next slide, please. Homes multiplied around the pond. Next slide. Along with marinas, country clubs, restaurants, stores, mini golf courses, and amusement park. Next slide. On a late afternoon of a summer weekend, the pond would be crowded with all manner of watercraft, canoes, kayaks, windsurfers, speedboats, sailboats, wave runners, and tour boats. You could hear children calling and splashing in the shallows, and the hearty laughter of adults enjoying a few beers on a backyard dock while stoking up the barbecue for that evening's dinner. But meanwhile, there was a growing danger lurking. So many people had built homes and businesses almost on top of each other. It would take tremendous cooperation and restraint to prevent damage to the quality of the Great Pond's water and the plants and animals that live in the water. But that would prove difficult because there were 4 different towns on the pond, 5 towns in the pond's watershed, in 2 different counties. And each town wanted to do things their own way. They formed a regional planning council that made astute recommendations, but still, each town maintained their independence. Next slide, please. 2,200 homes are directly on the pond, and many more in successive rings away from the pond. Only a portion of these homes are on sewer. The rest are on septic systems, any number of which are failing. Some are just primitive cesspools. On percolating soils, a septic system for a family of 4 would require about 20 acres of land for the septic effluent to be diluted by precipitation to the point that it would be considered safe. Here, on the rocky shores of the pond with little soils, there were many septic systems per acre. All that septic effluent washing into the pond. Over the years, so much of the land around the pond was paved, made into lawns, and otherwise hardened. So with each heavy rain, all the lawn fertilizers and other substances on the roadways and parking lots were washed into the pond. A disaster waiting to happen. Did anyone see this coming and sound an alarm? Yes, there were, but these voices went largely unheeded by the towns. The problem was that the corrective action at this point would be expensive and burdensome. The lake was loved, but loved far more than it could endure. On the day before the start of the summer season, following a series of intense thunderstorms and hotter than normal temperatures, next slide, clouds of blue-green algae began blooming in the water in quantities never seen before. The Land Environmental Protection Agency shut the pond down to any form of direct contact with the water, including swimming. The people were alarmed. The big weekend sputtered. pond-dependent businesses suffered as reservations were canceled and people did not come. Next slide, please. Meetings were held. Local officials and their representatives in the legislature demanded that the government of the land solve the problem because it's the public's pond. The Environmental Protection Agency came to the meeting. Local officials and the pond's state representatives excoriated the agency for closing beaches and alarming the public. Within days, bills were introduced in the legislature to procure funds to help rid the pond of HABs. But the thing is, harmful algal blooms are only a symptom. It is a dire warning that the pond is dying. Strategies that rid the pond of algae without addressing the underlying problems of eutrophication caused by an overabundance of nutrient chemicals and bacteria do not make the water safe. In fact, they funnel funds away from the needed strategies to stop the continuing flow of contaminants into the pond. But instead, some officials were insistent on this zany idea. Next slide, please. To introduce an exotic, non-native invasive species of algae-eating carp. You have heard about many technologies and strategies today. They all show promise, but I would put my money on the systems discussed by Dr. Abrupta that capture the stormwater before it enters the pond. I'm also looking forward to hear from Mayor Wilson, whose presentation is next. He will address the issues of septic systems in Jefferson Township. Who will pay for an effective restoration of water quality in Lake Hopatcong? The lake is owned by the state. When the Morris Canal was decommissioned, the state acquired it and dedicated the lake for the enjoyment of all the people in New Jersey. Those who are directly contributing to the flows of phosphorus and E. coli into the lake are the responsible parties. The responsible parties, which are the towns surrounding the lake, should come up with an equitable scheme so that the cost of capturing and filtering stormwater and of addressing wastewater issues is spread out across the 12,352 parcels in the Lake Hopatcong Hub 14, who directly contribute to Lake Hopatcong's water quality impairments. It is unfair and irresponsible to expect New Jersey taxpayers to bail you out. This is not your lake to pollute. It is ours. Stop polluting it. Next slide, please. It's time to talk about a common sense, equitable, and comprehensive strategy to save Lake Hopatcong. It is reasonable to ask the state to help, but only if the towns are willing to accept the extent that they have caused the problem and accept that they most directly have the power to solve the problem. And thereby hangs a tale.
Thank you, Elliot. I just want to tell you, I'm not gonna lie, you scared me a little bit with that, but it's well documented that increases in impervious surface impact water quality, and it is a good segue to the next session. The last discussion during this BMP session will focus on the successful septic system management programs in New Jersey. Many towns developed around New Jersey lakes were originally envisioned as vacation communities and have grown over the years, as Elliot just documented. The high density septic systems around these lakes can impact water quality if not properly maintained. Anywhere in the state where we rely on septic systems for the disposal of sanitary waste, it's imperative that the septic systems are properly designed, maintained, and functioning. Failing or improperly designed septic systems are a large source of nutrient and pathogen loadings to our waters. Here today is Noah Hetzel, Health Officer with Cumberland County Health Department, and also we'll have Mayor Eric Wilsussen from Jefferson Township to discuss successful septic system management programs. So first off, we have Noah. Noah, you want to take it away?
Absolutely. Thanks for having me. Can you guys hear me okay?
Yes.
Okay. So we didn't put all this together with HABs in mind. We have had very few HABs, and I think that has to do more with our rural community. We're pretty far spread apart, but if you want to go ahead and move to the next slide, we'll get started. We did have a couple problems to solve right off the bat. Sorry about that. We had, number one, we have to maintain a septic management plan, which is part of the water quality management plan that are held throughout the state. A lot of you who work in health departments and planning offices are familiar with this. It's where the state asks us to create an inventory of all of the septic systems in our community, and then figure out some way to reach out to the owners of these septic systems and communicate with them, the right way to manage your system, to make sure they're actually taking care of it, make sure it's not failing. We also had, beginning in 2012, the state introduced new septic inspection guidelines, which created kind of like a competing system where there was one road where people could do a septic inspection and they could get away with a lot more, or they could do it on the straight and narrow and turn the septic inspection into the health department to get it reviewed. Kind of created a little bit of an issue. We also saw a lot of predatory commercial practices where people were doing septic inspections, charging the regular fee, but maybe collecting a little extra from either the buyer or the seller to falsify what was actually happening with the system. Maybe they wanted a new system, so they slipped the inspector an extra $500 to fail it on purpose, or they slipped them $500 to fail or to pass a failing system. We saw a lot of that going on. And then we had a lot of failing or illegally installed disposal systems, stuff that was happening on the weekends or at night when nobody was around to watch. And then, we cover the majority of Cumberland County, with the exception of Vineland. So we have a pretty big area. I think 13 municipalities we have to cover. So we have to kind of wrap all that up and then present something that's going to solve all these problems with one. So move to the next slide. So what we did was we came up with the idea of Cumberland County Ordinance number 13. And there's a few different things within this ordinance, but the big catch-all is that anytime that anybody has to go through a real estate transaction for their property, they have to get a septic inspection performed, and they have to get it performed using the NJDEP technical guidance standards. If you guys aren't familiar with that, this was released in 2012 when the state changed the septic rules. Initially, there was a lot of confusion about it, and that's kind of what led to one of the problems we talked about earlier, was that people didn't really know and didn't understand how that worked. We spent a lot of time doing outreach. We, pushed the idea that, hey, if you do the inspection this way, you have to turn it into the health department to get it reviewed. Some people liked the idea. It protected the buyers. Some people didn't like the idea because it made a lot of the systems fail. We have a lot of records at our office, and if you have an inspection done and it turns out that you have a system installed at your house and we don't have a record on our files that matches it, that's a problem. It's got to be brought up to code. So now we have all of the inspections that are performed within our community, within our jurisdiction. They all come to Cumberland County Health Department for review. And all the systems that show signs of malfunction or need to be repaired or replaced, obviously we oversee all those permits as well. So everything that happens, for the most part, comes through us. Next slide. The benefits. So it established a standard practice for inspections within our jurisdiction, which is really helpful. We have about 50 different inspectors, registered inspectors who do business within our jurisdiction. Trying to get all those guys to do the same inspection the same way and submit the same report is a constant challenge. So we spend a lot of time doing outreach to them. Every year we hold a training where we bring them in and say, okay, this is what you guys got to do. These are some problems to look out for. These are the trends we're seeing in our community, and that seems to be really helpful. What has also happened, we didn't anticipate, is that those same guys do a lot of work in other counties, all of the surrounding counties: Salem, Gloucester, Atlantic, Cape May, and in Vineland Health Department. So the same guys are pretty much doing those inspections in those other jurisdictions, which I think has been really helpful for those jurisdictions as well, because everybody kind of sees the same thing. There are some of the older style inspections still happening You know, we can't control what happens outside of our jurisdiction, but within our jurisdiction, they're only being done in accordance with the tech regs. Through this process, or you know, one of the requirements of the septic management plan is that we have to maintain the ISSDS inventory for the state. So when we started this back in 2014, I think we had somewhere around 6,000 records. Since then, I think we're up to 9,982 is what I found when I looked in the system the other day. We have a total inventory in the county of about 14,000. You know, depending on the year, how many homes go through real estate transactions, we can add, you know, 600-700 properties to our list. So, you know, the list grows every year. I think this past year we added about 400 or 500 new properties to the inventory. So that's been a win for us. We've also discovered hundreds of illegally installed or malfunctioning systems, stuff that really wouldn't have been found or discovered otherwise. Like I talked about a minute ago, if someone comes to us and they have a system that is installed, you know, even though it's working correctly, but it was installed without a permit, or it was installed as a modification to a system. Say if you had a bed and all of a sudden now you have a bed and a seepage pit. Obviously, that's not a legal system, so we have to get everything corrected so that it is legal for the people who are going to be buying the property. This ordinance has also eliminated a lot of the predatory practices in the septic industry because the sellers or the inspectors can't really lead the inspection too much. You know, they can't just arbitrarily pass it or fail it. We have to have our set of eyes on it. And even though they put things in the report that try to generate revenue for themselves, they're not, the letters that we issue tend to take precedence for the buyers and for the mortgage companies, basically saying that, you know, everything, the system, our letter would say the system shows no signs of malfunction, whereas their letter, the contractor's letter might say that we recommend that the septic tank lid be brought up to grade. We recommend that the, you know, any number of things that they might recommend, but they're not actually supported or recommended, you know, through the septic code, chapter 7A. Next slide. So there are some shortfalls to this ordinance. Number one, it dramatically affected the real estate market, which drew a lot of political interest. Some of this was hearsay, some of this was legitimate. You know, we have a couple of communities that are really similar to what we just saw with Great Lake. Laurel Lake being one. The properties in Laurel Lake were built on extremely small lot sizes because they were all summer homes. They were all, you know, turn of the century. I think the Philadelphia Inquirer sold these or gave away these lots every year when people got a newspaper subscription. They got a 20 by 40 lot, and if you got 3 lots together, you could put a little summer cottage on it. Eventually, people just, you know, they didn't want to leave the summer cottage. They want to stay there all year round. So now you have, you know, houses being built or expanded on a 60 by 40 lot, and you know that's really too small for anything that has to support a septic system. But especially when you have, you know, 300 to 400 of these houses right on top of each other in a small community that surrounds a lake. So that's a concern. When you can't readily put in new septic systems on these lots without having the cost of the septic system be incredibly high. The ordinance does not cross jurisdictional boundaries, so the neighboring counties, you know, they still have the ability to do things differently, even in Vineland, which is in Cumberland County. They have to, you know, they have the ability to change things up as they want, which, you know, we always get the, oh, well, I'm allowed to do this in Cape May. I'm allowed to do this in Salem County. Okay, you're in Cumberland County, so you have to do things as we do things in Cumberland County. So we deal with a little bit of that.
You know, I'm sorry to interrupt you, but can you give you about another minute to wrap things up?
Sure. Last, the ordinance relies on township support. So what we really rely on is the township giving out COs every time there's a new homeowner coming through. And part of the CO process is that they have to, or part of the CO process for most of our communities, say they have to actually get the septic inspected. They have to have a letter from us in order to get their CO. Most of the townships do this. Most of the townships don't, or a few of the townships don't. So we have to go through a little bit of chasing records on that end. So next slide. The impact. So township inventory, like we said, we had 9,980 currently in the system. Inspections performed between 2014 and 2021. We had 2,271 total, approximately 325 per year. Next slide. Repairs or alterations between 2014 and 2021, 1,878 total, approximately 268 per year. That's a 35% increase over the number of applications that we saw in previous years. So I think we were down in the hundreds, like 160, 170, something like that. So it has been a really big impact. We're seeing a lot of systems get it upgraded. So we're moving in the right direction. Obviously, we have a pretty big way to go. And I think that's pretty much it. Last slide. Yep, that's it. So if you guys have any questions, hang out for a little bit.
Great, thank you, Noah. The follow-up presentation by Mayor Will Sussin from Jefferson Township on their septic management program. Mayor?
Thank you very much. Appreciate Kerry for the invitation to participate in today's HAB Summit. I was able to attend last year, and so it's very informative, and certainly appreciate a little input. Next slide. Just a little background. I've served as our Lake Shawnee Club president since 2007, which I'll talk a little bit about our lake. I'm on the Lake Apacon Commission since 2016, and as of 2019, became the mayor of the Township of Jefferson. Next slide. Lake Shawnee, the reason I bring up Lake Shawnee is because Lake Shawnee really started our septic management program, was kind of the pilot for the township. Although I wasn't mayor back then, I was the president of the lake, so I was involved in the implementation of the township's septic management program using Lake Shawnee as a pilot. And one of the reasons it was used as a pilot is because our lake was developed back in 1946 by the Arthur D. Crane Company. It's an 83-acre lake. We have 544 properties surrounding the lake, various levels from lakefront to off the lake. We have a very active 13-member board of governors and an active lake ecology committee that even before all the testing of phosphorus and nitrates and you name it, Lake Shawnee was pretty active ourselves without being told by any organization to test our lake. We were always very concerned about the water quality of our lake and took steps pretty much well ahead of many before we ever heard of harmful algal blooms and such. We were always very concerned about the water quality of our lake and the preservation of it. So we try to be good caretakers of our lake. Next slide. Lake Shawnee sits at the very, very, very top of the Musconetcon watershed. Pretty much it all starts at Lake Shawnee, and in the hills and valleys surrounding our lake flows through Lake Shawnee to Lake Apacon, then all the way out through, of course, to the Delaware River. So we are basically the headwaters of everything that flows down through the watershed. Next slide. In 2006, Princeton Hydro did a study of Lake Apacon, and it showed that Lake Shawnee was contributing to about 7% of the phosphorus load into Lake Apacon, and that sparked some conversations and basically led us to led the township into entering into a septic management program. Next slide. In 2002, the township had completed a sewer feasibility study, which included pretty much most of the areas surrounding the watershed, the Lake Shawnee lake, through all the shoreline properties and properties off the lake surrounding Lake Apacon, in the what we call the Lake Apacon section of the township. Covered about approximately 5,400 homes. Basically at that time, the cost was estimated to be about $65 million. I, of course, was not the mayor at the time, And but it was my understanding from trying to research some of the history of what happened and why Jefferson never completed sewering of its lakefront. It was mainly because the cost had escalated and primarily loans and funding had dried up. And to shoulder the cost among just the users would have been astronomical. Fast forward to 2019, harmful algal bloom hits Lake Apacon. We know that obviously septics and the phosphorus and nitrates do contribute to the overall phosphorus load to the lake, which can help help the harmful algal blooms grow. We took it upon ourselves to try to find some funding to revisit our feasibility study, and the Highlands Council was agreeable to funding a update to our feasibility study, which is actually we were just awarded the money, and we'll be updating our feasibility study. Unfortunately, one of the other things that happened when the Highlands legislation came into New Jersey was that the portion of Lake Shawnee was actually cut out of Lake Shawnee is all in the preservation area, which does not allow sewering. So going forward, if we were to actually do any type of sewering, Lake Shawnee is a key component with those 544 houses to reduce the cost overall of the project. We would have to get some exemptions to get Lake Shawnee because for the most part, the sewering cannot be completed in a preservation area, so we would need some exemptions for that to make the whole project feasible for financial reasons. Next slide. So in May of 2017, Lake Shawnee became the pilot program for the entire township to basically work out the kinks and bugs of a septic management program. They used us mainly because we had an established organization. We could educate our community, which we were pretty much already doing at that point already. We knew the importance of getting septic pumped well before septic management programs became popular. And then in 2014, the entire township went to a mandatory septic management program. Next slide, please. So Lake Shawnee became the testing program. We began a testing program, I should say, in conjunction with New Jersey DEP. We did a pre and post test for to see what effects septic management would have. Overall, as far as the phosphorus load going into Lake Apacon. I tried very hard to get my hands on those results, and anybody who was involved in the program could not find them. So I relied on Dr. Lubnow from Princeton Hydro, who I call Dr. Lake Apacon, because anything you want to know about Lake Apacon, Dr. Lubnow certainly is the source. But the results did show a drop in phosphorus. I know for a fact that it did show a drop in phosphorus from implementing a septic management program in and around Lake Shawnee. Next slide, please. And I just want to talk real quick because I know that just want to mention that Dr. Lubnow had sent me some information as far as the studies that have been done, testing that has been done on Lake Apacon and the outfall from Lake Shawnee into Lake Apacon. And his information that he provided me showed that a pre-ordinance nitrate and post-ordinance nitrate study showed a 25% reduction in nitrates. And I'm reading what Dr. Lubnow had sent me. Based on the reduction in nitrates, more than likely dissolved forms of phosphorus would also have a decline from pre to post ordinance conditions. So we did see an actual decrease in nitrates and phosphorus to Lake Apacon. So our ordinance is called a Subsurface Sewage Disposal System Management Ordinance for the Township of Jefferson. Next slide. And I'm not going to read the whole thing, but just basically says that, more or less people are going to participate in the program. We manage it here through our health department. Our residents have to receive a permit, and actually we can go to the next slide. Our residents can get a no-fee permit from our health department. Each homeowner is required to obtain what we call an operator's permit, which is how it's worded in the ordinance. They're required to pump every 3 years, and it has to be done by a licensed pump operator, which also who performs an inspection to make sure that the septic is performing properly to the best of what they can do on a visual inspection. And we, manage, as I said, through our health department. It's notices go out every 3 years to remind people that they are due up for a pumping. And then once they get the septic pump, they're required to provide us a copy of their receipt from the pump operator. Either the homeowner can do that or the pump operator submits them directly to our health department. And we keep a ongoing database just to ensure that compliance. The one thing I will say, just on the aspect of president of the Lake Shawnee Club and as mayor, it is definitely a constant education. We constantly have to remind people the importance of maintaining their septic system, what they can and can't put into it. Many people come from areas in which they're used to having a sewer system, and they're not familiar with how a septic operates. So we are constantly educating people as to the importance of maintaining a septic. And as you just heard in the previous presentation, we know how costly septics can be with a lot of the new laws today and such. So it really pays for people to participate in the program and maintain their septic. So we know that also that septic management is just a temporary solution. I know myself, after being involved in the Lake Hopatcong Commission, and being part of those discussions and some of those large meetings at Hopatcong High School, and dealing with some angry residents and people who use the lake. We know that septic management is not the save-all end-all. We know that at some point sewers have to come, and thus the reason why we are updating our sewer feasibility study, so that we're constantly looking for funding opportunities into the future, that we can get our portion of Jefferson Township that surrounds Lake Hopatcong sometime in the future, hopefully sewered, to help to protect our lake. Thank you. Appreciate it.
Thank you, Mayor. I appreciate it. I was just going to give you a warning, but not necessary.
I knew it was coming.
Thank you very much. So we do have a couple moments for some questions. This wouldn't be the right place to have a debate on stormwater utilities, so I don't think we're going to entertain that. However, I think stormwater utilities are a tool for municipalities, and communities and municipalities need to decide what's best for them. I think that we all can agree that there's a lot of people that really do love and care for Lake Hopatcong, and I think for that we're all grateful. I did see one question up here. I'm going to scroll up. There was a question about, does Cumberland County septic ordinance require pump out every 3 years? Noah, you still with us?
Yep, still here. It currently does not. I mean, eventually we would like to get that far once we can finish building our inventory, and that is something that the state is requiring. But we're not there yet. We don't have the capacity. We don't have the internal structure set up for that. When we look at our inventory of being 14,000 people, it's just there's no way to police that well.
Thank you, Noah. I do see another question. Is there a penalty or enforcement action if the 3-year pump out is not performed? So I guess that's for you, Mayor.
We do have a penalty portion. We try to get compliance more than gain the fees. We give them, obviously we start out with a warning, and then it progresses from there. And I don't know off the top of my head what the actual penalty is, but I know there is one built in there to issue summonses. Yes.
Thank you. There's a follow-up question. Is there a different pumping schedule for people who live on the lake full-time versus people who only use their homes on a part-time basis?
In Jefferson Township, no, it's all just a plain straight 3-year pump out.
Okay. What does the Lake Association do if people do not pump out their system every 3 years? Okay, so you already covered that.
The Lake Association is not the regulatory, it would be our health department.
Okay, and I do see a hand up. I'm trying to find out whose hand that is.
Yeah, that's mine. That's mine. My name is Brad.
Okay, Brad, go ahead. If you want to ask any questions.
I was the one who asked the questions about is there a different pumping thing for full-time or part-time, and whether or not there's a, for example, if they don't comply, right? Does that mean that you suspend their membership, or how does the non-compliance work if you're using the Board of Health?
The Lake Association we have no regulatory enforcement ability whatsoever. The Lake Association is really just the conduit for education more than anything else. So it's really our Department of Health that regulates the ordinance and any compliance issues. So the Lake Association really has nothing to do with it.
Thank you very much.
We do have another question from Clean Ocean Action. How is the tracking so far about compliance or non-compliance?
And for Jefferson Township, our compliance is actually very good. We have a database. We use a SDL, Strategic Data Logic, is our software company. They track, as the permits come in. And letters go out they generate the letters and such. So it's really easy to track. It really is.
Noah, do you want to weigh in on compliance at all?
Well, compliance is really difficult. And I think one of the biggest problems we have is, Cumberland County is a really poor area. And when you're trying to get people to do things like pump their septic system out, they're in a situation where that $500 that they have to pump their septic system out is $500 that could have fed their family that month. And we're always in a struggle with that. And that's one of the things where we're really hesitant to dip our toe in the water on the 3-year pump out rules. We're really at this point in time focusing on trying to get compliance at the point of sale, because that's when there's money flowing in both directions. There's interest in selling the property, there's interest in buying the property, and to make that happen, the mortgage company wants to see that everything's functioning and on up to code. So we spend a lot of our time, at that point of transaction rather than trying to get compliance down the road.
Thank you, Noah. And I think we're going to need to wrap it up. We're about 10 minutes over, but that's not terrible for a full day. There was one additional question from Elliot stating, is it fairly easy to get a Highlands exemption to extend sewer service to address failing septics? I wouldn't necessarily say it's easy, either through the Highlands or getting a sewer service through the WQMP program. But certainly if it's a failing septic, that does give additional justification to add it to the sewer service area. So I'll hand it back over to Carrie. Thank you.
Thank you, Bruce, and thank you, speakers. That was great. Really appreciate all of the great information that you shared with us. So at this point, we're going to be moving on to our next set of discussions, and this is we'll be covering HAB's impacts to drinking water, and that session is going to be moderated by Chelsea Brooke. Chelsea is the Executive Assistant for our Water Resource Management Program in the Assistant Commissioner's Office. Chelsea?
Thanks, Carrie. Good afternoon, everybody, and thanks for hanging in there. I know it's been a lot of information today, so thanks for staying with us. As Carrie said, my name is Chelsea Brooke, and I work for Assistant Commissioner Pat Gardner. I'm part of the team that has been working on the development of guidance and policies with respect to cyanohabs in relation to drinking water. I will be your moderator for this segment of the HAB Summit, where we'll be focusing on those issues. First up, we're very fortunate to have Dr. Suzanne DiLorenzo, who currently is working as a lab supervisor at Passaic Valley Water Commission. She's going to be sharing an overview of the challenges faced by the city of Salem, Oregon, as they experience cyanotoxin impacts to their drinking water in 2018. Then I'm going to give you a brief update on steps that we are taking here in New Jersey to address potential risks to cyanohabs impacts to drinking water. And then hopefully we'll have a few minutes at the end for questions. So without further ado, I'm delighted to introduce Dr. Suzanne DiLorenzo.
Thank you. Okay, well, I'm sure that most of you who are still on the phone are kind of wondering who the heck this person is who's talking to you about what happened in Salem, Oregon. So just real quick background. I spent almost the past 15 years in the state of Oregon. Half of that time was spent in water quality. So I didn't work for the city of Salem. That was Lacey Goer's Priest, who was running water quality down there at the time. I was the water quality manager for Clackamas River Water, which is just about an hour north of there. But when this event happened, I was loaned out to the Marion County Emergency Operations Center, where I was a subject matter expert. It really just helped translate things for people around there. So let's just dive right into it. Next slide. Is a very complicated story, and there's so much that goes into it. I touched upon every step of the way, every layer of this onion I was involved in some way, shape, or form. So while I was in Oregon at that time, I was the chair of the Oregon Water Utility Council, so I was even involved in the legislative response that happened after this. I kind of wrestled with what aspect to talk about, but essentially I just settled on I'm just going to tell you the story. It's another cautionary tale about what happens when you're not expecting to find something that you've actually been looking for a very long time. Next slide. So the cover slide was actually a picture of Detroit Lake. So if you weren't completely mesmerized by its beauty, take another look. It's Oregon, so it's big and it's beautiful and it's flowing down from snow-capped mountains. Detroit Lake was actually, still is, the city of Salem's primary source of drinking water for about 80 years. And that's a reservoir that's fed by the North Santiam River. It hits this reservoir that's actually managed by U.S. Corps of Engineers. It is not for drinking water. It is primarily for flood protection and regulating fish flows back out into the North Santiam, where eventually it splits around Guerin Island, which is where the city of Salem's slow sand filtration plant is. People in Oregon like to brag about the quality of the water supply. It's a huge point of pride. So even after this event, it's still a great water source. Next slide. The thing with Detroit Lake is, as big and beautiful as it is, like many of the lakes around the country, it was subject to regular cyanobacterial blooms during summer months. This was not something new. It wasn't something completely unexpected. A recreational advisory was issued on May 23rd, 2018, due to levels of cyanotoxins in the water. And if you can see that picture on the right, Sam was out there monitoring. That sample was taken on the 21st, just a few days before. So we knew there was a big bloom out there, but Oregon drinking water providers were actually voluntarily testing for toxins since 2011. The Oregon Health Authority had set their own advisory levels. We all had cyanotoxin monitoring plans. But the interesting thing was we all had plans, we were all looking for it, but we all had different plans, different responses. And a lot of times those responses to finding a toxin just simply reverted us back to the Oregon Health Authority. Next slide. So Salem's out there since 2011, and they're looking at their cyanobacterial and algal populations. But the reality fact is for Salem, their primary focus was on filter clogging algae. So the picture that you're seeing to the right is actually a clip of a slide from a presentation that they gave in 2015 at an AWWA conference. And you can see that there's actually a green algae bloom forming on top of this low sand filtration bed. So this was an issue for them. It would clog the filters, it would cause taste and odor issues, it increases operational demands, everything runs slower at a time when you need to be pumping water faster. So they're looking for these types of blooms. And you can see from the second bullet point on their slide that they were pretty convinced that their slow sand filtration would remove any toxins that would be in the source water. And that's not an outlandish claim. If you know anything about drinking water treatment, you know that slow sand filtration is actually pretty good at removing cyanotoxins. But if you hit any sort of treatment process with enough of a contaminant quickly enough, it doesn't have time to adjust, and you can get some breakthrough. So in light of all this, despite testing since 2011, there was no real plan in place for the city of Salem to follow if they actually found cyanotoxins in the finished drinking water. Next slide. So here's the timeline of what's going on. I've highlighted on the right, the watershed on the top, that's Clackamas, where I was. The one on the bottom is the North Santiam and the Santiam watershed. So that's the city of Salem's watershed. As you can see, our watersheds kind of butt up against each other, so they're pretty similar. On May 25th, Salem becomes aware of a cyanotoxin detection in their drinking water, their finished drinking water. It's above the EPA health advisory levels for vulnerable populations, which is 0.3 micrograms per liter of microcystin or 0.7 micrograms per liter of cylindrospermopsin. They were finding both of these toxins at varying concentrations at varying times. May 25th, again, if you work in drinking water, you know, it's a Friday before a holiday. Everything that can go wrong will go wrong. So this is right before Memorial Day. So there's a lag between when they find the cyanotoxin and between May 29th when the city actually decides to issue an advisory. Once that happens, there's a lot of fallout. June 1st, though, city is able to lift its drinking water advisory after it had 3 clean samples, only to put it back in place on June 6th, which is an issue, obviously. Ultimately, this leads the Oregon Health Authority, OHA, implementing new rules for testing cyanotoxins. And so let's go over what happened between May 25th and May 29th. Next slide. So Salem, as far as I know, becomes the first city to implement a health advisory off of EPA's 2015 cyanotoxin health advisory levels. At least they're the very first for the state of Oregon. So all drinking water providers are watching right now and learning. The thing is, if you read these, you know that applying a health advisory could be kind of complicated, and it did prove really challenging. So issuing that guidance and communicating it, understanding it, and then explaining to the public is difficult. This sentence right down here, health advisories provide the cyanotoxin levels in drinking water less than or equal to which adverse human health impacts are unlikely to occur over a 10-day period. If you are part of the general public and you understood that at the first shot, congratulations. But that's something that a lot of us in the drinking water industry really had to work through. So public notification was initially delayed because the city staff was consulting with the Oregon Health Authority drinking water program, and they're trying to decide what to do. And they interpreted that as they have a 10-day window in which to issue an advisory. So in this 10-day window, they can make operational changes. So they were working on blending water and trying to get those levels down. But as you can see, a direct quote from Dave Emmy, who was the manager of drinking water service at the time, this delayed notification ultimately spurred public outrage. Next slide. Okay, so what was going on? Well, City of Salem is trying to institute operational changes, but of course, all things going wrong on a holiday weekend, there winds up being a major break in the transmission main coming from Garrett Island. So that diverts a lot of attention. Ultimately, on May 29th, there's a meeting held between the public works staff, OHA, EPA, and the emergency manager, and they decide it's time to issue an advisory. The emergency manager, acting in the best interest of the community, notifies the school district and other partners. That's at 2 p.m. At 2:15 p.m., the school district notifies the parents before the advisory is even released. This causes a lot of panic and a lot of misinformation, as you can imagine. The Do Not Drink the Water advisory isn't released until 4:30 p.m. with a press release. What took so long was the Oregon Health Authority wanted to review all the language before it went out. By 5:15, the emergency manager asked Marion County to send an integrated public alert and warning system alert about the advisory. So that's an iPause. So if you ever gotten one of those really loud alerts on your phone letting you know something big is happening, that's what they were trying to do. But Marion County wasn't able to do it. So they contacted Oregon Office of Emergency Management. Oregon Office of Emergency Management gets locked out of the iPause system and has to call FEMA for help. By 8:30 p.m., Salem finally gets a message out, but it's the wrong message. It needed to be targeted at Marion County. It went out to 3 counties. So 3 counties got the wrong message. And I bet you're all wondering what that message was. Next slide. The message read, emergency alert, civil emergency in this area until 11:28 p.m. Prepare for action. So here come a flood of calls to 911 as residents of 3 counties in Oregon are trying to figure out what exactly this civil emergency is that they should be preparing for. This didn't get corrected until 9 p.m. It's just the default message. It was sent by accident. So now we have finally our do not drink advisory is out there after a little bit of panic. It's limited to the vulnerable population. It's a do not drink as a precaution, which the public has trouble comprehending from the start. Do not drink and precaution are very confusing in the same sentence. And so many thought that the water was unsafe to drink and they wouldn't drink it. So bottled water flew off the shelves of any store anywhere near Salem. That picture is not from the pandemic. It's from a Kroger store down in Salem, although I'm sure that the shopping carts tipped over for dramatic effect. The governor had to call the National Guard on May 31st because there were fights over bottled water and a lot of panic and price gouging. Next slide. Meanwhile, poor Salem is getting skewered in the media. Salem gets test results days before issuing do not drink water advisory for young kids. So people are super ticked off about this lag. They don't understand what was going on, and they feel that Salem is hiding things. Next slide. But there's another reason for some of the lag. So toxin testing. Oregon is a gigantic state, yet there is no in-state capacity for testing for cyanotoxins. We're all, as drinking water providers, sending our samples out to different places. So my organization sent it to the very tip of Michigan. Salem was sending them to Ohio. Some folks were sending them to Texas. The city of Wilsonville was lucky enough to be able to find a spot in Seattle who'd run some of their samples. The thing is, though, sending out of state creates a lot of delay. Sometimes unnecessary delay. So these delays in reporting can result in confusion. So you issue a do not drink and then you lift it, but then you get your test results from, 2 days ago saying that, oh no, you have another spike in a cyanotoxin. And this is what happened when the second advisory was put in place on the 6th. They had to put the advisory back in place because cyanotoxins, if you've ever measured them, they're not always in a bloom linear. They don't just they're up and down. They peak and they valley, and they're all over the place. So the ability to get really quick results and information is really important when you're managing a cyanotoxin event in drinking water. So public confidence is further eroded. Kudos to Salem, though. Their lab got set up by June 27th to run those cyanotoxins in-house. So they scrambled, but they did get it done. That second advisory is finally lifted on July 3rd. Next slide. So in the meantime, however, 170,000 people in the Salem metro area need water. Marion County finally activated its Emergency Operations Center. That's where I went. And that helped kind of smooth some of the emergency response. Salem went to go get its emergency distribution tankers, only to find that they were rusted out. They've been sitting a lot for years. No, one of them was rusted out. The newer one, actually, someone had left the hatch open for a whole year, and so it's quite rainy in Oregon. So those tankers were rendered useless. But with the help of the Emergency Operations Center, we were able to get emergency water distribution trailers out and stationed in various places in the Portland metro area. So the Regional Water Providers Consortium is essentially just all of the drinking water providers in the Portland metro area up north. We sent down 5 emergency water distribution trailers to Salem. The National Guard was able to provide more tankers and personnel. Fun fact, though, is that the Regional Water Providers Consortium never got these trailers thinking that we'd use them in a cyanotoxin event. We got them through FEMA grants, planning for earthquake response. So we were all pretty surprised that this was the first time that we had to use them. And then meanwhile, Salem and Marion County Emergency Management were able to work with social service agencies and nonprofits to identify people in need, because you still have to get water to people who are vulnerable and can't make it to the distribution site. So they actually did a really great job. It was a little slow to start, establishing contact and sharing information, but once they got it rolling, they did a great job getting water where it needs to go. Next slide. So for those of you who did not pay attention in your 7th grade geography class, Salem is actually the capital of Oregon. And there is no better way to get your lawmakers to pay attention than to bring a crisis directly to their house. So Oregon legislature was in session while this happened. And they were also under a do not drink advisory. So there was a lot of pressure to do something and respond. So on July 1st, OHA had published those temporary rules that required all drinking water providers with source water that was deemed susceptible to sample for these toxins. That's basically at that point any surface water system. The analysis needed to be run within 1 business day. We had to have results back in 3 days. This was a quick turnaround time that we were all worried we couldn't guarantee. So the Oregon DEQ stepped up. They got themselves a cyanotoxin automated assay system and started running ELISA samples for all water systems through October 2020. So that was really great. And that was free of charge. Those rules became permanent on January 1st, 2019 with very little changes. So we had a sample from May through October. But they required the labs to be certified by the Oregon Environmental Laboratory Accreditation Program, or LAP, to run cyanotoxins. This didn't exist. Or we could run them at the DEQ. It was called out specifically in the rule. So drinking water providers went down to the DEQ budget hearing, and we pushed pretty hard to get more funding so they could keep running our samples, and we were successful. So DEQ is still running drinking water samples through today. Next slide. Also stemming from this, the harmful algal blooms work group was formed, which I was a part of. It was established by Representative Ken Halb at the end of the 2019 legislative session, and we were going to study Oregon's response to HABs. What was neat about this was it brought everyone together at the same table. So state agencies, municipalities, local water districts, drinking water, sewer water, and environmental advocates, we were all there at the same table, working towards the same goal. We came up with 5 primary recommendations for the legislative consideration in the 2020 session. The first one was compiling a comprehensive list of existing programs, which seems maybe silly or superficial, but what we learned by talking to each other was we were all doing things that we didn't realize the other was doing. And we thought we could get ahead and save money and be more productive if we all worked together. But first, we needed to know what was going on out there. That report was completed a couple months ago. The second was creating an expert advisory council. This was simply grow out of the harmful algal blooms work group. And it was just a group of experts who would just check in once or twice a year after the work group was done, just to make sure that progress was continuing. Funding for additional equipment, specifically for the DEQ, they were running only 1 CAS system. They only had one. So if that went down, they would be in big trouble. So we pushed for funding for that. More staff and supplies for sampling, because a lot of these lakes that would experience blooms are actually quite remote. So we need to get people out to those reaches, because we used to be able to do it in Oregon, but funding gets cut. So we wanted that put back in. And then funding for outreach and coordination to small utilities. This was a neat one, because when I was in the EOC, I was actually helping the smaller towns on the Santiam. This is a story that doesn't just impact Salem. There are a number of smaller towns along the North Santiam that were impacted. We're talking towns of people of 500 or less. So having someone established, dedicated, that these towns knew and can talk to, we thought was really important. And all 3 of these last bullet points were successfully funded. And actually, they were just advertising for the outreach coordinator. So we're really happy to see that. Next slide.
Suzanne, hi.
Suzanne, oh, sorry, Carrie. I was just going to say we just have like a couple of minutes and we have to wrap up. Sorry.
We got 1 slide.
Perfect.
Lessons learned. What did we learn? Preparedness. I'm sure a lot of you have heard that. So community preparedness is number 1. So promoting individual emergency preparedness, which is tricky to get people motivated to do this. But only 8% of people in Salem actually had water stored in case of an emergency. Up north in Portland, we would push for pretty hard for individual emergency preparedness, again, because of the earthquake, not realizing that it can translate for both things. So that's what you see, the 14-gallon challenge. Nothing can replace that. City and utility preparedness, activate your emergency operations center early on. It can help kind of smooth over a lot of those communication meltdowns that Salem saw early on, especially on May 29th. Have a plan and practice it. So you betcha we all sat down on a tabletop exercise and practiced our plans just a few months after. Improve your communication infrastructure and practice it. So if you or you have a partner who is going to do communication for you, make sure that infrastructure is in place before the crisis. And then ensure your emergency equipment has regular maintenance schedule. And then finally, communications. Never, ever underestimate the impact that an advisor can have on the public. Never. The lack of experience in messaging, if it exists, is going to transform an advisory into public relations crisis. So what you want to do is, in your organization, create a culture that values communication skills, not just technical skills. So in the drinking water industry, we tend to value the technical skills a lot. We have people who are good at their job and they get it done. But we need to start placing value on people who can communicate what's going on. Those soft skills are equally important. Next slide. So that's all I have. If you have any questions, I'll take them whenever appropriate. And thank you.
Thanks, Suzanne. We're going to take some questions at the end. So yeah, we'll just quickly, I know we don't have a ton of time, but again, just please put your questions in the chat. And Suzanne, if you can respond to any of the questions you see in the chat that are for you while I'm speaking, even better. So thank you again. That was really enlightening. We appreciate having you here in New Jersey and giving your time and experience to us. Suzanne has been a valuable member of our HAB surface water system work group that we've started here in New Jersey. Next slide. So I just want to reiterate what some of the speakers here today have already mentioned. We are seeing an increase in reported and confirmed cases of cyanohabs, and also in 2020 we saw an increase in the number of cyanohabs that impacted drinking water sources. Just to clarify, these were impacts to the raw water source, not the finished treated drinking water. And when we talk about the thresholds that a declared cyanohab is based on, they are the recreation standards created for the raw water sources, such as risks for swimming. So on the other hand, we use both health advisories developed by EPA and guidance thresholds developed by DEP's Science and Research to indicate a problem with cyanotoxins in the drinking water. Next. So in 2015, the EPA developed health advisories for 2 cyanotoxins, for cylindrospermopsin and microcystin. What is a health advisory? As Suzanne touched on before, it's a non-regulatory concentration of a finished drinking water contaminant that someone could be exposed for 10 days without any adverse health effects. And in 2018, the Division of Science and Research developed guidance values for microcystin and cylindrospermopsin that were lower than EPA's health advisories, and they also developed one for anatoxin A and will likely be developing one for saxitoxin in the near future. I noticed in the previous slide that we're seeing an increase in raw water detections of cyanohabs. So what's happening in the finished water? Well, during, somebody had mentioned the comment in one of the previous presentations, they brought up EPA's unregulated contaminant rule number 4. So as part of that UCMR 4, cyanotoxins was one of the many compounds that they were monitoring for. So here in New Jersey, out of the thousands of samples from over 100 systems, there were only 2 detections noted at 1 sampling event and location, and the results were both below EPA's health advisory number. And it's not too surprising because we do know that conventional drinking water treatment, consisting of coagulation, sedimentation, filtration, and chlorination, generally removes cyanobacterial cells pretty well and low levels of toxins. However, with UCMR4, systems were following a predetermined schedule, so they're not exactly sampling when they were having a bloom. So it may have underscored any actual presence of cyanotoxins. This past summer, again, as Suzanne mentioned, everything always happens right before a holiday. Same thing here as last summer before Labor Day weekend. This time, there were 2 systems, one particular we were dealing with right before Labor Day, who were sampling due to their own protocols that experienced cyanotoxins in their finished water. They were both below EPA's health advisories as well as New Jersey's guidance values. But in seeing that, we realized UCMR4 data might not have been as good of an indicator as maybe we thought it was, and we realized we really, need to do some more. So as a result, in August of 2020, DEP notified all surface water systems that any detections of cyanotoxins needed to be reported to the department. In September 2020, DEP requested cyanotoxin management plans be submitted for all public community surface water systems in accordance with our emergency response regulations. And in September 2020, DEP developed a HAB surface water system work group that continues to meet monthly. The purpose of the meetings is to discuss common issues facing systems with respect to HABs and cyanotoxins. It's kind of a forum for folks to vet different issues, but also the main point is to help collaboratively develop guidance and policies to reduce those risks, as well as to develop public education materials. So on all kinds of topics, prevention, mitigation, testing, treatment, notification. And again, this is a very quick overview because I did not have a whole lot of time allotted here to what we're working on. And we do have a few minutes for questions. So I am going to go to the chat. I don't see any hands raised. So again, in this slide at the end was just if anybody wanted to see the difference between the DEP's values versus EPA's values. So let me see if I missed. Okay. All right, so Brighton Technology asks Dr. DiLorenzo, when I just realized I didn't have my camera on, sorry. Is there a database of the cyanotoxin results for multiple public water system testing for microsystem and cylindrospermopsin? And I will say at least, you can get the UCMR data, but we do not have anything specifically in New Jersey.
Yeah, in Oregon, it's a yes and no. So we have a system that's very similar to Water Watch, where we post all of our sampling data. So you can find from 2018 on all of that data for drinking water systems. The city of Salem does post the results of every single cyanotoxin sample that they take now in the interest of transparency. But there's no true database just for the cyanotoxins. It is something that we were discussing amongst the work group right before I left, but I don't know the status of that.
Okay, and I guess there was one more question for you too, Suzanne. They asked, what is the water treatment of the treated drinking water in Salem and along the Santiam River? And with the monitoring beforehand, what is thought to be the trigger in that watershed system?
So Salem uses slow sand filtration. Once this happened, actually, they scrambled and they were able to put together a mixer with powdered activated carbon before it hit the slow sand filtration, which causes issues, but it does help. The Schmutz deck, my favorite word in drinking water, did eventually change, and it was able to break down those toxins, and now they should be just finishing up an ozone treatment. One of the smaller systems was doing really good. The city of Gates, they actually had a membrane filtration system that was pretty successful at removing the toxins. As far as the trigger, this is a tricky one. So there's a couple of things. Some of it is how the water is managed. It's a U.S. Army Corps of Engineers dam. So it literally takes an act of Congress to change how the water moves and flows, and a lot of environmental studies as far as how it would affect salmon. On top of that, it's a pretty well-maintained area, but climate change is a major factor. That whole area, including those small towns I helped, was decimated by the Beachy fire this summer. So when those forest fires run through, it basically dumps a whole bunch of phosphorus all at once into the system, which can then be stored in various areas within the reservoir and really kick up blooms. So there's a lot of research going on it.
Thanks, Suzanne. And then Elliot Ruga asks, what was the cause of the HABs at the Canisteo Reservoir, which is well buffered by a deeply forested area? I'm not sure what the exact cause is or was, but the Newark Newark City Water Department was required to submit a cyanotoxin management plan, as they are public community surface water system. So, you know, the causes and, you know, looking out for potential indicators of blooms, you know, hopefully that will be fleshed out in their cyanotoxin management plan. But I don't know if anybody else, you know, in Bruce's shop wants to try to address that, but I'm not aware of any causes that were identified with canister specifically. Nope.
So I don't see anybody jumping on, so I'll help you, Chelsea. We didn't actually have a HAB on canister in 2020. It was 2019 was the last recorded HAB there, and it was isolated to the shoreline. You know, just because it's well buffered, unfortunately, doesn't protect it from potentially getting a HAB. Even lakes with low nutrient levels have been reported to have HAB outbreaks. So it could be internal loading and cycling, you know, from nutrients being released from the bottom sediment. Could have been a number of reasons, but again, we didn't see it in 2020.
Yes, Chelsea, this is Felipe Contreras from Kleinfelder. We're actually doing the project for the city of Newark, and we're monitoring canister this year. And as they mentioned before, we didn't have an event in 2020, and we did submit the cyanobacteria management plan, and we just finalized a pollutant loading analysis for all the watershed that includes the 5 reservoirs for the city of Newark. So we're expecting to have some answers on that a specific topic, but we didn't see anything in particular. Again, highly isolated, low residential, forested. So it is really hard to establish how we're getting these events. And again, it was a very isolated, shore-related incident. And we do have an extensive plan with the Echo Lake reservoir, where we have experienced more events of HAB events in the past, where we have 6 ultrasonic units that are currently under evaluation. We probably didn't have, well, we certainly didn't have enough data to be participating in this seminar with real data comparison, doing a true comparison between the ultrasonic units and the graph samples that we've been taking to validate the data. We have a monitoring unit in Canister and another one in Charlottesburg, which is the main reservoir for the city of Newark. So we are working on exactly this. Thank you.
Thank you, Philippe. And with that, I'll turn it back to Carrie, because I know we are running short on time.
Thank you, Chelsea, and thank you, Suzanne. Your talk was quite interesting, and as another commenter pointed out, particularly in the area of communications. So thank you for that, and thank you, Chelsea, for the update from New Jersey. At this time, I'd like to turn it over to Gene Shebra. Gene is our Assistant Director for Municipal Finance and Construction, and he's going to be talking about financing HAB projects. Gene?
Thank you, Carrie. Next slide, please. So here to talk a little bit about the water bank. I know there aren't many arms left in the bullpen, so I'm going to throw my pitches quickly to leave it for the post-game wrap-up. But pretty much the water bank can fund anything that is water quality improvement or protection related. So next slide, please. It's a partnership between EPA. We get our seed money from EPA, and we leverage those funds with the iBank. It's a highly successful program. We've issued over 1,700 project loans worth over $8.7 billion to date. Pretty much funded every government entity in New Jersey. That is the downside of the program, that our funding is limited to government entities. Next slide, please. So the loan structure is up to 30-year term loans or useful life of the project. We can't we can't issue a 30-year term loan for a project that has a useful life less than 30 years. There are no application deadlines. And no award deadlines. We have rolling applications, rolling awards, and it's based pretty much on rank and readiness to proceed. On the drinking water side of the ledger of the water bank, it is based on priority. We are experiencing a little bit of a shortfall on the drinking water side of the ledger. Next slide, please. The application process is all online. The system is called H2 Loans. I will provide a link at the end of my talk on how to access that, that system. Next slide. So part of our intended use plan, we're using EPA funds, so we have to publish a document every year on how we intend to use those funds. And so we did have a category in our intended use plan this year for water quality restoration that would address harmful algae blooms. Like I mentioned, we can fund pretty much anything water quality improvement or protection related. We kind of take pride in being creative on what we can fund and how to fund a project. Some of the projects that Chris had mentioned, swirl separators, constructed wetlands, rain gardens, we could fund those type of projects. Next slide, please. Now, unfortunately, the funding is limited. We have $10 million set aside for water quality restoration projects. It's not a lot of money. Principal forgiveness is another term for a grant. It's a loan that's forgiven. And in order to spread that $10 million around, we have a $2 million per cap, $2 million cap per applicant. The structure would be 50% of the loan would be forgiven, 25% from DEP at 0% interest, and 25% from the iBank at market rate. So presently, interest rates are very low. So that residual loan amount would, if you were to close right now, would be near a 1% interest rate for that residual loan piece. Next slide. We can skip this slide and the next slide. So yeah, I wanted to focus on this a little bit. Again, you know, these are some of the examples of the type of projects we have funded in the past. Again, any stormwater management, rain gardens, green infrastructure, gray infrastructure. We can provide upfront planning money. Those loans are on a shorter term. They're 3-year term loans that have to be rolled over into a capital improvement project. Next slide. Again, a couple more examples, porous pavements that Chris had mentioned. So you could take a project like a parking lot and we would fund ripping up that parking lot and putting in porous pavement or a rain garden or bioswales. And like I had mentioned, I pitched very quickly. I will be sending out my contact information. If you have any interest at all, like I said, the program likes to take pride into being creative on the type of projects we can fund and how to fund it. I will send out my contact information right now and leave the rest of the time for questions.
Thank you, Jean. Any questions for Jean? I don't see anything in the chat, and I don't see any hands up. So does anyone have a question? I'll give you just a second to raise a hand, or otherwise put something in chat. All right. Seeing none, we're going to move on to our final speaker, who was one of our opening speakers, and that is Vic Peretti, who is the section chief for the Bureau of Freshwater and Biological Monitoring. He's going to be talking about opportunities for meter partnerships. Vic?
Thanks, Carrie. Go to the next slide, please. So I'm going to be talking about our new phycocyanometer loan program. These meters have been touched upon in a couple previous presentations, and we've greatly increased the use of these field phycometers with our partners for screening and status monitoring. They're a very effective tool, and they greatly enhance our response efficiency. They're actually fluorometers. They measure the relative fluorescence of phycocyanin pigment unique to cyanobacteria. They're easy to use. If you could dip the tip of it in the water and press a button, you're all set. So I'm going to give you just a brief overview of how we use these and how you could participate in our loan program. So next slide, please. So this graph shows one of the correlations we developed between cell count and phycocyanin measurements. We use this using all of our New Jersey data to date. Again, these are meter specific, so different models of meters have different ranges. So this graph is specific to the handheld meter that we're going to be loaning out to our partners. So we use these as an initial screening to determine if a HAB is present at all in the watch or above range. If it is, we'll collect samples. For confirmed HABs, they're used to monitor changes in the HAB conditions. So the phycocyanin measurement shows that a HAB is moving toward a different alert level. For better or for worse, samples are taken to confirm the appropriate alert is in place at all times. So for instance, if an initial screening for a suspected HAB is above 12, we would collect the sample to confirm that the HAB is present and at what concentrations. So if you see on the this orange arrow, if we're monitoring an existing HAB that may be in the watch range, starts approaching a meter reading of 44, we know that's starting to get possibly into the advisory alert, possibly a beach closing range. So we would collect the sample to confirm the conditions, whether they warrant a change in the alert posting. And again, this is particularly important for beaches. If they're in that alert level between 40,000 and 80,000 cells per mil, we want to make sure the most appropriate protection to the public is posted. And again, these measurements are for screening. They're not intended to replace lab analysis or used to determine actual alert postings. And also they don't approximate toxic concentration. These correlations are for cell counts only. Next slide, please. So far, we've provided meters to 3 parks regions and Spruce Run Reservoir. 9 additional meters were provided by EPA, and we loan those out to other partners within the state. We have identified a contract vendor, and a purchase order is in progress for 17 more of these meters. EPA, again, is going to help us out. They believe they have additional grant dollars, and they're pursuing the purchase of more meters to loan us so we can in turn loan them to partners. We developed a training video. There's a link right here to show you how to use these. And again, very simple to use. It's only a less than 5-minute video. So I encourage people to take a look if they're interested in getting one of these meters to loan. Next slide, please. So if you are loan one of these meters, what are the expectations? So for DEP, we'll coordinate the meter maintenance and calibration. If there is a likely HAB based on the meter readings, we'll provide confirmation laboratory analysis. If you help us out with sampling, we'll provide bottles and coordinate the sample delivery. For partners, the expectation would be to provide us with a direct contact person. We would ask that you take meter measurements for screening and status as requested, that use the DEP HAB reporting system that I talked about earlier, to submit measurements and other site information. And, basically inform us of any meter issues, and we'll take care of those, make sure it's always properly working and calibrated. We hope to provide these meters, wherever they're needed, but depending on the amount of interest, we're going to have to prioritize who we loan these out to. So, basically, high-risk water bodies, drinking water sources, water bodies for recreation, water bodies for recurring HABs. That's how we're going to prioritize how these are loaned. If it turns out that we don't have enough to loan everybody. Next slide, please. So here's my contact information. If you could please email me your organization name, the primary contact person, and the water body or water bodies you're interested in monitoring. We'll put you on the list and determine the candidates and get back to you soon on loading these meters out. So if you have any questions, I'll be glad to answer them.
Vic, the only question I see that you haven't already answered is the cost of 1 meter. What is the cost?
They're about $1,000, give or take. I think another the standard might be another $100 that you need to just for calibration.
Yeah, I know. This is Fred from Princeton Hydro. We've purchased a set of meters where you get a chlorophyll A meter and a phycocyanin meter from Turner Design, and that set is $2,500. So you're right, Vic. You're right around 1,000, a little over 1,000 for just the phycocyanin.
Vic, there's a comment in the chat about Bob didn't understand the bullet pertaining to sample bottles and sampling. Bob, do you want to just clarify what it is you're looking for so that we're clear so we can answer appropriately? Bob? Babalu, are you there?
Yes, I'm here. I'm sorry. Looking for my connections. I'm sorry. I just didn't understand. I mean, as I understand it, this is about using meters to determine fluorescence, but I don't understand how the sampling and sample bottles factor in. Thank you.
Okay, so these approximate the cell concentration, the meters. So if it's a confirmed HAB, already existing, and the levels look like they're going up or down, or if it's a suspected HAB and it looks like, yeah, there may in fact be a HAB there, we would ask that samples be taken so we could perform lab analysis. So we would be able to train you how to do that. We would provide bottles so we could they could be delivered to our lab for analysis, and we would arrange the delivery and coordinate that also.
Excellent. Thank you. I appreciate that.
I'm not seeing any other questions in the chat or a hand raised. Last call, any questions before we get to our closing remarks? All right, seeing none, I'd like to turn the summit over to our Associate Commissioner, Katie Angerone, who was with us this morning doing welcoming. So, Katie?
Carrie, I do see a late-breaking hand, and I don't want to... Oh, I think you've been muted, Carrie.
Did I ask a question still?
Yes, please go right ahead. Sorry, I didn't see you.
Rick Ferrugia. We are going to be installing inlet protection devices with bags, high quality stainless steel frame with high quality bags to collect silt, sediment, preventing it from getting into a lake. And I was wondering, could we consider placing some of the biochar material in those bags and getting a benefit of phosphorus reduction from that?
I'm not, Rick, is that directed to Vic, or did you?
Maybe anybody who wants to answer, perhaps.
Or maybe even Fred.
Then Hydro?
Yeah, I mean, that's certainly feasible. The one thing to keep in mind is if the water's flowing, what we have found is the efficiency is not as high as if it's in standing water, and that's just because of the duration of the duration of contact.
Yes.
Number one. And number two, because it's flowing, you may have to replace the bags at a higher frequency. So depending on the nutrient load, they say they should be replaced once every 3 to 6 months. For a flowing system, you may need to replace them every 2 to 3 months. That's some of the stuff we're working on with some of our projects now to sort of tease that apart. And then, as Heather mentioned earlier, particle size is something else you can play with to try to figure out what best works for your system.
Right, right. Okay, great. Thank you.
Okay, Katie, I think it's all yours.
All right. And I love the conversational nature of today, despite the fact that we were up over 200. Thanks very much, Carrie. And this looks like it was a long, but I'm sure a productive day. Before touching on what's on the horizon for this year, I just want to thank you all so much for taking the time to participate and learn more about the department's continued HAB efforts and each other's efforts. In particular, I really want to thank the speakers who shared their knowledge and their expertise, as well as the communities who shared their data and their lessons learned. That's so valuable. And I'm so impressed with the hard work that our HAB-affected communities are doing to address the stressors in their watershed and to respond to active HABs. It's clear to me that we are stronger and more effective when we partner. Whether we are working with our lakes commissions, our local officials, our NGOs, or our regional planning groups like the Highlands Council, I'm confident that we will continue to collaborate, and with shared information that we are absolutely making progress. Make no mistake, of course, there's more to do. So I'm glad we were gathered here together today. And if there's one positive that comes from having to move to a virtual format, it's certainly that we had an increase in attendees, as I said, and the amount of people we were able to reach. Despite COVID, the department continues to work remotely, and our HAB efforts have not slowed down one bit. Currently, we are continuing to develop guidance documents for public water systems relating to HABs, including prevention and mitigation of HABs in your water source, treatment of cyanotoxins at the water treatment plant, and guidance for the issuance of public notifications for cyanotoxins in finished drinking water. And we're also developing fact sheets and FAQs for HABs, as well as drinking water public notice templates for cyanotoxins. And DEP is working collaboratively internally across our programs to get convenient low detection test kits approved for public water utilities to use on site when sampling and monitoring for certain cyanotoxins. And we're also working to review all of our surface water system comprehensive monitoring plans to provide feedback that will assist our water systems with monitoring and prevention of HAB events. And currently, the interagency HAB work group is in the process of updating the New Jersey freshwater HAB recreational response strategy, which we expect to be released this spring. As always, DEP continues to review and use the best available science for enhancing the strategy and to inform our response actions. In the meantime, there is now the ability for anyone to download all of the HAB data that's been collected to date. That's very exciting. Analyze away, folks. And we are also so thankful to the partners that help us respond to the HABs and communicate alerts to the public. We will continue to work to expand that network. And we encourage everyone to sign up for our new HAB listserv to keep abreast of the latest HAB-related news and to visit our website for the latest outreach and training materials. And finally, we are excited to say that we expect the new harmful algal bloom expert team to provide guidance for lake managers in the coming year. So with that, I'll say thank you again for participating. Stay safe and have a great evening.
Thank you.